Next we move on to properties of fluids. It have compressibility and bulk modulus. The compressibility is defined as the reciprocal of bulk modulus. The bulk modulus, what is meant by bulk modulus means direct stress by volumetric strain. The direct stress means whether it may be tensile or it may be compressive, whatever may be. Direct stress means it may be tensile stress or compressive stress, whatever may be. Depending upon the situation, we can acquire it. Then surface tension. So volumetric, before that we have to discuss the compressibility. In bulk modulus we have the term volumetric strain. So volumetric strain means there is a change in volume to the original volume. So ratio of volume changes, what will be the changes in volume to the original volume of the component. So this is the compressibility and bulk modulus here. Then surface tension. They are defined as a force acting on the surface of the liquid in contact with gas or in the surface between two immersible fluids, such that the contact surface between like a membranes and a tension. So these are the main things here. So then capillarity. It's defined as the phenomena of rise or fall of a liquid surface in a small tube related to the adjacent general level of a liquid when the tube is held vertically in the liquid. The rise of the liquid surface is capillary rise, while the fall in the liquid surface is known as capillary depression. So the capillary rise 4 sigma divided by rho gt, whereas in depression of capillary 4 sigma cos theta by rho gd. So where the theta specifies the angle between the liquid and glass tube. Then what are the different kind of fluids we can study or analyze in our fluid mechanics? The first one is ideal fluid. A fluid which is incompressible and is having no viscosity is known as ideal fluid. Ideal fluid is an imaginary fluid. So incompressible, it means the density never change. So throughout the system, wherever we can consider the density of the fluid should be in constant, wherever we need to analyze or check. So that is the incompressible fluid. That is the main thing in analysis. Then real fluid. A fluid which possesses viscosity is known as real fluid. Actually all the fluid we consider as a real fluid, because any kind of fluid it has some viscosity. So we have to consider any kind of fluid in a real fluid. Then Newtonian fluid. The Newtonian fluid, a real fluid in which the shear stress is directly proportional to the rate of shear strain, is called Newtonian fluid. Shear stress is directly proportional to the shear strain. We call it as Newtonian fluid. Likewise, it just opposite to that, we can call it as non-Newtonian fluid. What it means, the non-Newtonian fluid means the shear stress is not directly proportional to the shear strain. That is called as non-Newtonian fluid. Then ideal plastic fluid. A fluid which shear stress is more than the yield value. What is that yield value? Yield value means where it starts. Mostly the Newtonian fluids or non-Newtonian fluids or real fluids or ideal fluids. So all of the things we consider from the origin. Origin means where x comma y is equal to 0 comma 0. X is equal to 0, y is equal to 0. So we consider likewise. But in ideal plastic fluid, the yield value, the value starts with some positive values. Positive whole values, not start with 0. Or not start with the origin. So that is ideal plastic fluid. So it specifies a fluid in which shear stress is more than the yield value. And shear stress is directly proportional to the shear strain. We call it as ideal plastic fluid. So these are the things we need to mention here. Then types of flow. What are the different kinds of flows we are utilized in fluid mechanics? Steady flow. Steady flow in which fluid characteristics like pressure, density does not vary with respect to time. That is steady flow. In any time frame, the pressure as well as density, viscosity never change. It should be in constant. So that is steady flow. With just opposite to that, there is a change with respect to time. The pressure density means we call it as unsteady flow. The unsteady flow in which fluid characteristics like pressure, density, etc. vary with respect to time. It will change with respect to time. So that is the unsteady flow. Then uniform flow. So the uniform flow, the flow in which velocity at any given time does not change with respect to distance. So the velocity never changes with respect to distance. Velocity always same. So wherever may be. So that is the major thing here. So velocity. So in a flat surface, the velocity have a different kind of flow rates. Where in a slope, it have different kind of flow rates. That should be avoided. We need to keep the things in the same manner. So that means we have to maintain the same velocity in both slope as well. The surface whatever may be, but we need to maintain the velocity should be in the limit. So that is uniform flow. Then non-uniform flow. It's just opposite to the uniform flow. A flow in which the velocity at any given time change with respect to distance. Then compressible flow. So we discussed in our early stages the flow in which the density of fluid changes from point to point. So density change each and every point means we call it as compressible fluid. So it's very difficult to analyze. So we never utilize these concepts in our futuristic or regular analysis purposes. So we have to neglect this kind of aspects. Then incompressible means the density the system throughout the process should be constant. So then only we can analyze in a much easier, and then we can get the solution in a right way. Otherwise, it's very difficult to access certain things.